Welcome back to Spring Into Math 6. This is Mr. Stein with you here again, and today we're going to talk about prime factorization using factor trees. So, prime factorization. So when we have a larger number and we are factoring, we may need to use what's called divisibility rules to help us find the factors of a number. Okay, so what are these divisibility rules? So divisibility rules help determine if a number is divisible by, let's say, 2 or 3 or 4. So they're really kind of helping you to get an idea if a number is divisible by certain numbers. It's kind of like a shortcut where you might not have to divide it into a different number. So this can help us to identify the factors of a number. Here's a chart that shows all of the basic divisibility rules. So I'm going to go to the next screen in a second and show you the chart. I'll read through the first one, then I'm going to flip to another graphic that looks similar. It's the same rules, just in a different way. I want you guys to pause and write down the main ones that, some of them are pretty obvious, like 2, for instance, obviously if it's an even number. But some of the ones that are a little tricky, I want you to pause the video and write them down in your math journal so that you have them. Okay, so the divisibility rules. Okay, so to be divisible, it means that it's able to be divided evenly with no remainder. Now, after about 5th grade, you realize you can divide a number by anything. It's just going to have a remainder or a decimal. But to be divisible by something, it needs to go in evenly. Okay, so let's look at 2. So if the last digit is even, it's divisible by 2, kind of like what I said. All right, so the number 3. Now this is where it gets a little bit trickier, and you might want to pause at different points and write these down. So 3, the sum of the digits is divisible by 3. So it means if you're adding the digits together, and then it's divisible by 3, the whole number is divisible by 3. All right, 4, if the last 2 digits form a number that is divisible by 4, then it's divisible by 4. All right, 5, if the last digit is a 5 or a 0, and that's a pretty basic one, it's divisible by 5. 6, the number is divisible by both 2 and 3. So if a number you can divide it evenly by 2 and 3, it's also divisible by 6. All right, 7, now this is a kind of a weird one. You can double the last digit and subtract the sum from the rest of the number and set an answer that is divisible by 6, including 0. So that's a really tricky one. I personally think if you're trying to figure out if something's divisible by 7, it's actually just easier and faster just to divide it by 7 and figure it out yourself. I mean, for me to do a long division problem is going to be faster than doubling the last digit, subtracting it from the sum, and then dividing it by 7 anyways. But that's just my personal opinion on it. But I want you, to know the rule. All right, the number 8. The last 3 digits form a number that is divisible by 8. The number 9. If it's divisible by 9, the sum of all the digits is divisible by 9. That's kind of a good trick. If you just add all the numbers together, if you can divide it by 9, the whole number is divisible by 9. All right, and 10, the number ends in a 0. So that's a pretty easy one as well. All right, so here's another way of looking at it, and there's a little example there. So remember, the 7 was kind of the trickiest one, so I'm going to look at that one again. So you double the last digit, you subtract it from the rest of the number, and if your answer is divisible by 7, then the whole number is divisible by 7. So to me, again, it seems like a lot of steps rather than just dividing, for instance, in this example, 574, just dividing it by 7 and seeing if it goes in evenly. All right, so at this point, pause or go back to the last screen, pick whichever chart you like better, and write down those key rules. All right, so now let's jump into prime factorization. So prime factorization of a composite number is the number written as the product of its prime numbers. Now, you can use factors and a factor tree to help find the prime factorization of a number. Now, I know it sounds like a lot of different things. It's really not so hard, and you've done things like this before. So a factor tree is complete only when prime factors appear in the product. So let's look at an example of this, and then you'll really get a good idea of what I'm talking about. All right, so remember, you can use the divisibility rules if they help you. All right, so we're going to complete the factor chart for the number 60. So you can see here it's kind of already a pre-filled out chart. Most of the times you're just going to be given a number and you're going to have to make your own factor tree. So, and in this example, this template is giving you circles for where you'll put the prime numbers and squares where you're going to put composite numbers. Now, there's other ways to do this, and I'll talk about it briefly at the end, but let's kind of go through this one. So our explanation of the number 60. So first we look at all the factors of 60. So you're going to notice that one of the factors must be broken or must be able to be broken down twice. So we have several choices to choose from. All the factors except 10 and 6 would work. So let's choose one. So you can see the factors. We have 30 and 2, 20 and 3, 15 and 4, 12, 5, and 10, 6. All right, so if we choose 2 and 30, so we put the 2 in the circle box because it's a prime number. Then we have 30. Then we're going to break 30 apart. We're going to split 30. So if we split 30 again, we split it and we have 15 and 2. So we put 2 into the circle for the prime circle, and then we have 15 in the composite box, and then we break 15. And so 15 breaks into a 3 and a 5. So the factors of 60 are 2 times 2 times 3 times 5. And if you were to sit there and actually multiply, 2 times 2 is 4, 4 times 3, and then 3 times 5, you're going to get 60 because 4 times 3 is 12, and 12 times 5 is 60. Now, this is a great way to do it. My personal opinion, when you're breaking down a number like 60, it's easier if you just split it as close as possible. So if I slide back to the last slide, you can see here, and I'll kind of try to highlight it for you, that 10 and 6 are factors that are very close. So when I'm breaking down numbers, I would always choose 10 and 6 because they're closer together. And then from there, I would just break down 6 into 2 and 3, and 10 into 2 and 5, and I would have all my numbers. It's just easier. But that's if you really understand the factors of a number. But if you're looking at the number 60 and you're not so sure, and you know that at least it's a even number, start there. You can always break it down just like this, pulling 2's out of numbers or whatever number you know, and it's a great way to do it as well. So whichever way works best for you, I'd say go for it. All right, so thanks for joining me, and I'll see you next time.